In this video, I will be going over lesson 9, which is about inequalities. Our first question says that Genevieve has saved $56 and works at a part-time job for $12 per hour. She wants to have at least $200 by the end of the week. Which inequality represents this situation if X is the number of hours that she works? Okay, so one thing here is we want to read these questions carefully because the keywords are going to tell us which way our inequality should be facing. And with inequalities, it's always best to, plug in some numbers and see if it makes sense with how it's facing, right? So I know she has $56 already, and then she's also earning $12 an hour at her job. So if I want to have at least $200, I need to add how much money I'm going to have total, right? I already have 56, and I want to add that to how many hours I'm working. So these two answer choices with our subtraction signs in the middle, we don't want those because we're not taking out how much money she already saved, right? Because that wouldn't make much sense. The next part here is figuring out which way our inequality sign is going to go. And if I look, she wants to have at least $200, okay? So if she has like $180, is that at least $200? Say she needs $200 to buy, I don't know, what's $200 she could buy? Say she needs $200 to buy this really fancy dress. And if she goes to the store with $180, is she going to have enough to pay for it? Well, no, right? She's missing $20. So her total needs to be something that's either $200 or bigger. So say I were to have something like $210. That is bigger than 200, right? So our big side of our inequality wants to face this 200. So we want to pick C. And remember the line underneath an inequality means or equal to. So we have greater than or equal to, meaning if I showed up with $200 to buy my $200 dress, I could also pay for it because I have just the right amount of money. Our next one says that Natalie is shopping for new clothes and does not want to spend more than $65. She buys one dress for $26 and wants to buy a few shirts that cost $13 each. Which inequality can she use to determine the number of shirts she can buy X? Okay, so she's only buying one dress, and this one dress is $26. She is buying multiple shirts, right? It says she wants to buy a few shirts. So here's that word each. Remember, I said each is a keyword that whenever you see this word each, whatever number next to it, that's what you're attaching your variable to, right? So this 13 is going to have our X. So these two right here that have the X attached to the 26, we're automatically crossing those off. Okay, so now I'm adding that one dress I'm buying and however many shirts I get, but she does not want to spend more than $65. So if she spends $70, can't do it, right? Because that's more than 65. Say she only spends 60. And here I have my 65. 65 is bigger, which means I want the open side of my inequality here to be towards my 65. So I'm going to pick this equation down here. Our next one. So we're taking that equation that we first did for Genevieve, and now we are solving it. So the first equation that we got was this 12x plus 56. Oops. 12x plus 56. And let me double check my inequality. Greater than or less than 200. Okay, perfect. So now let's start solving it. When we're solving inequalities, we solve these the same way we do equations, except instead of an equal sign, we just have this inequality here. So I want to get rid of this plus 56. So the opposite of adding is subtracting. So we're going to subtract 56 from both sides. I have a 12x here. My inequality sign, I'm going to bring straight down. I'm not changing the direction or anything. And then we have some subtraction here. So this is going to give us 144. And you can type that into a calculator if you want to double check it. From here, I need to get 12 away from my x. So the opposite of multiplying by 12 is going to be dividing by 12. So I'm going to have x is greater than or equal to 12. 144 divided by 12 is 12. So when you're picking your answer, you always want to double check and make sure that our inequality sign is facing the same way. Okay, it's very easy to accidentally click this one because we're looking at the 12, but double check your inequality signs and make sure they're facing the right way. Our next question says that Patricia wants to buy a new phone and the cheapest one she likes is $175. Each week she earns $25 from babysitting and a paycheck from an hourly job. This inequality represents what Patricia needs to earn, where X represents the number of hours needed to work. Which statement is true about the solution for the inequality? Okay, so it looks like 12 is, that was weird. It looks like 12 is the common number in all these answers, right? So we're going to go based off of our inequality sign here. If when I solve this, I get X is greater than or equal to 12, what this is telling me is that this X number here, if Patricia were to work 11 hours, 11 is not bigger than 12, which means that she wouldn't have enough money to buy her phone. 12 is equal to 12, and that works. Let me move this up here because it's a bit hard to see. 12 is equal to 12, and that works here because this on the bottom, this right here represents or equal to. So if she works at least 12 hours, she's going to be able to afford her phone. If she works 13, she'll also be able to afford her phone. So this part right here where it says Patricia needs to work at least 12 hours to save enough money for her phone, that is the correct answer. So that at least 12 means at the minimum, she has to work 12. She can't work any less than that because if it's anything less than that, she's not going to have enough. But if she works anything over that, then she's also fine. Our next question. So here we are going to solve that inequality for Natalie. So I'm going to look back at our inequality, which we chose this 26 plus 13x is less than or equal to 65. So I'm going to rewrite that. 26 plus 13x is less than or equal to 65. Again, we're going to start by getting rid of this 26. Opposite of a positive 26 is going to be a negative 1. Subtract that from both sides. And this is going to give us 31, I think. No, that can't be right. 39. There we go. Always double check your subtraction in a calculator if you're unsure. Then to get rid of this 13, opposite of multiplying is dividing. So we're going to divide both sides by 13. And we're going to get x is less than or equal to 3. So that means that the maximum number of shirts she can buy is 3. So she can buy at max 3 shirts. The maximum number of shirts she can get is 3. Our next question wants us to do some more solving. So we're going to solve some inequalities here. I'm going to rewrite this down here. 9 minus 3x is greater than 30. So let's start by getting rid of this 9. This minus sign is still attached to my 3, so I have negative 3x. And 30 minus 9 is going to be 21. So here, this is a rule. And you need to make sure that you remember it. So I'll write it up here, and I would also write it down. So anytime you are dividing by a negative, you flip your sign. Okay, and what that means is that here, to get x by itself, I need to get rid of this minus 3, right? The negative and the 3 they both need to leave so that x is just by itself. So I'm going to divide both sides by negative 3 here, okay? These 3's are going to go away, and I'm left with just x. And this 21 divided by negative 3, double check this, double check your signs by typing it into a calculator. I'm going to get a negative 7. But because I divided by a negative here, this rule comes into play. And what I mean by flip my sign is originally my arrow, my little inequality sign, is pointing towards the right. I'm going to flip it so that it's going the other way. You can see from right here to here, I'm flipping my inequality sign so it's now going the other direction. Okay, so that means that our answer should be this one here, where I have x is less than negative 7. And you have to remember this rule because so many kids make mistakes, or they get the right answer, but they forget to flip their sign, okay? So if you're doing a checkpoint and you could have sworn that you did everything correct, and maybe you marked it wrong, double check that your sign is facing the right way. Okay, so here's another one. We're going to solve this inequality. So I have 10 minus 1/2 x is less than negative 18. So let's get rid of this 10. 10 is positive, so I'm going to subtract it from both sides. I'm left with negative 1/2 x is less than negative 28. I'm going to divide by this negative 1/2 on both sides. And I'm left with x. And then when I type this into a calculator, negative 28 divided by this negative 1/2, I'm going to get a positive 56. But remember, since I am dividing by this negative sign here, I have to flip my sign. This sign in the center needs to now flip to the other direction, so it's going to go like this, which means that my final answer for this one is going to be this, x is greater than 56. So when you're solving these, don't be afraid to type all these steps into a calculator to help you with your signs. Especially here, if when we did this subtraction, if we didn't get this negative 28, our answer would be completely different, right? So don't be afraid to do this in your head, and then also type it into a calculator just to double check, just to make sure we're getting the right numbers and the right signs. All right, that is all that I have for lesson 9. If you have any other questions, please let me know.